Alright, we're going to talk about periods of sine and cosine functions. So here I wrote the formula, or the rule for period. Period is 2 pi over the absolute value of b. So you just gotta follow this rule when I'm just asking for period. Make sure you memorize this. Now in our first example, we have y equals 1/2 cosine of 1/3 angle theta or 1/3 theta plus pi over 4. Now, there's something I should mention, that there's a different form. It's a small change. So y equals 1/2 cosine. Now sometimes you might see 1/3 theta or theta over 3 plus pi over 4. So I just want to mention that. Sometimes you might see a number in front of theta, like 1/3, or sometimes you might see theta over 3. So what happened was just theta multiplied by 1 is just theta, and it's on the top. So if you have this, then it's easy for you to convert it and pull out the fraction or factor out the fraction. So it's just a small change. So make sure to be familiar with these two types, alright? So 1/3 theta is the same thing as theta over 3. Alright, as usual, we're going to identify our A, B, C, D. So A is 1/2, B is 1/3, C, remember, is always the opposite of this. So let me underline this, A, B, C. So since it's positive, or I mean plus pi over 4, it's going to be negative pi over 4. And then for D, there's no number after the parenthesis, so I can just put 0, or you could put none, but 0 is sufficient. Now, this one is that we're asking for a period. So, again, here's a formula for period. So all we're doing is finding period. So the value for period, or what we're going to use, is the b value. So we're going to have 2 pi on the top over the absolute value of 1/3. Alright, so once you find the absolute value, it's just simply 2 pi over 1/3. Now, we can't leave it like this. So what we're going to do is I'm going to write the work here. We're going to work out this so it's a number being divided by a fraction. So it's 2 pi over 1/3. Since it's a division problem because it's a fraction, it's the same thing as 2 pi divided by 1/3. And then in order to work with division of fraction, we're going to rewrite it as a multiplication. So 2 pi divided by 1/3 is the same thing as 2 pi times 3 over 1. All I did was flip the second fraction, the reciprocal of the second fraction. That's all I did. So 2 pi divided by 1/3 is the same as 2 pi times 3 over 1. That's all I did. So remember, it's a whole number, 2 pi times a fraction. All we do is going to multiply to the numerator. So 2 pi times 3 is 6 pi over 1. And then 6 pi over 1 is simplified to just simply 6 pi. So the period of this example is 6 pi. So to review, we use our b value, took the absolute value, which is just 1/3, and then I rewrote 2 pi over 1/3, which is a fraction, into a division problem. So 2 pi divided by 1/3. Since I don't like dividing with fraction, I changed it to multiplication and flip the second fraction. So instead of 1/3, it's now 3 over 1. a whole number times a fraction to simply multiply to the numerator, which is why I got 6 pi over 1. I simplify that to just 6 pi. So the final answer is period is 6 pi. Alright, in our third example, we have y equals negative 1/4 cosine of 6x minus 3 pi over 4 minus 2. Now, even though we have x in here, it's still the same operation if it was just theta. So don't worry about that. Next, we're going to identify A, B, C, and D. So the A value is negative 1/4. Our B value is 6. Our C value is, since it's minus 3 pi over 4, is just positive 3 pi over 4. And then our D value is negative 2. Alright. Period 2 pi over B. So 2 pi over the absolute value of B, which is 6. And then when we do the absolute value, it will be 2 pi over 6. And then we can't just stop there. The reason is because we can still simplify this. What's in common between 2 and 6? They're both even numbers. We can divide top and bottom by 2. So we're going to have 2 pi divided by 2 will be just pi as your numerator. 6 divided by 2 will be 3. So our period is pi over 3. So that's our period. So you always have to check if you can simplify. In this case, yes. So our B value was 6. We took the absolute value of it, positive 6. So when we had 2 pi over 6, we see that 2 and 6 are both even numbers. Both of them can be divided by 2. So when I did that on the numerator and the denominator, we got pi over 3. That's our final answer. So period is pi over 3. So always check if you can simplify. Now, in these three examples, our B value was positive. Keep in mind, sometimes B can be negative. Like in the previous video for amplitude examples, there are some B values that were negative, even the A value. So, had this been a negative 6, when you do the absolute value, it would just come out as a positive 6. So again, absolute value just makes the number inside become positive. So, keep that in mind. Don't assume that B will always be positive. So again, do not assume B is always positive. B can be positive or negative. That's why we have the formula 2 pi over the absolute value of B. So again, period is 2 pi over the absolute value of B. Alright, in our second example, we have y equals 2 sine of theta over 2 plus 5 pi over 4 minus 6. Now, we can rewrite this as y equal 2 sine of, so since it's just simply angle theta on the top, we can write it as just 1 as the numerator, keep the denominator, and put angle theta on the side. Now again, the reason I wrote 1 as a numerator was because it was just only angle theta. Had it been such as 5 angle theta, then my numerator would have been 5. Had it been 7 angle theta, my numerator would have been 7. Here we only have 1 angle theta, so my numerator is 1. Alright, so let's identify our A, B, C, D. A is 2, B is 1/2, C, it's a plus 5 pi over 4, so it's going to be a negative 5 pi over 4. And then D is minus 6, so it's negative 6. Alright, so we got our A, B, C, D, but period is just simply using the B value. So I'm going to write the work here, period is 2 pi over, which is our B value. Now remember, we're doing the absolute value of B. So when that happens, 2 pi is the same on the top. The absolute value of 1/2 is just 1/2. Alright, so it's the same thing as the last example. We have a fraction. So 2 pi over 1/2 is the same thing as 2 pi divided by 1/2. Now since I don't like working with division in regards to fractions, I'm going to change it to multiplication and flip the second fraction. So now it's 2 over 1. So all I did was convert 2 pi over 1/2 into 2 pi divided by 1/2. Now I change it to multiplication, where it's now 2 pi times 2 over 1. A whole number times a fraction, multiply to the numerator, which is 4 pi over 1, and then we can simplify that. 4 pi divided by 1 is just 4 pi. So our period in this example is 4 pi. So when you're having a fraction as your B value, you would just follow this process just like in example 1 and example 2.